So, good afternoon, everyone. Thank you for joining me today. I would start with imagine like inheriting a financial system where the critical tax work was still runs on the Excel sheets and a part of the software. Okay, if and one formula goes wrong, okay, or miss the dates, it's the cost for the clients and us also. Okay, so for that one, we have actually transitioned from the old system to the new one with the combination of Fabric and with the zero trust financial services architecture. Before we talk about the solution, let me quickly introduce myself. Over the years, I have been able to work on the few of the bigger organizations like Airbus, Board Pro, Telstra, and where I have learned the kind of a small implementations which I have used, okay, for my current company. So every single one taught me the same lesson. Technology changes fast, but the real differentiator is staying curious. As the Satya Nadella, CEO of Microsoft, said, don't be a know-it-all, be a learn-it-all. That mindset actually exactly what drove this project. Today I'm going to share what we learned while turning decades of legacy pain into a secure, scalable project. Let me show you that what was the actual before implementing the new system at TM&Z. The engagement and the customer was managed across the several disconnected system. Most of the heavy lifting still happened in Excel sheets with the team relying on personal memory and manual efforts. Because of these systems, we could not talk to each other, okay, with the constant missing sales opportunity, and customer experience was suffered, and honestly it was hurting the reputation of the brand also. Ultimately, Team NZ wants to grow into a modern trusted financial service provider for our client. So that was the pain we were dealing, and the big question was how do we move from this chaos to proper compliance system. The answer started with the clear version to build a zero trust principles with the fabric. For the we didn't just want a faster system, we want a secure and compliant one. We applied three core principle while implementing it. Verify explicitly every access, every data movement must be authenticated and authorized. Least privilege, given just enough access or just in time to the people who are going to use that data. Assume breach. So we implemented the design so that if something is compromised, the blast radius is minimum. So Microsoft Fabric becomes the perfect data engine to deliver this vision, acting as one-stop shop for ingestion, transformation, governance, and analytics. So all while integrating the tightly with secure Azure services. Actually, it was our North Star. With the vision set, let's look at the new system we built around it. Then we name it Skynet. Skynet is our modern Azure native platform. At its core, Azure Container Apps, API management, orchestration handled beautifully by the service bus, Signal R, keywords, and private endpoints, all sitting in a clean hub and spoke topology. Everything is deployed using the infrastructure as code, either the Bicep or YAML pipelines with the multi-level Azure DevOps pipelines. As we got a system that is efficient, robust, and far less dependent on a single person. Even with a great application layer, the data layer was still the biggest challenge. Skynet gave us the application layer, but security and compliance were non-negotiable. Here's how we applied zero trust principles across the entire architecture. If you see, this is the actual our implementation for the Microsoft Fabric. We use the private endpoints and VNet for isolation, keywords and manage identities for least privileged are back everywhere. Application insights and log analytics gives us the continuous monitoring, so we truly assume the breach. And in Fabric, sensitivity levels, row level securities, and data masking for our most sensitive financial and identity data is being used. That is what secure, compliant architecture looks in a practice. While the application and security layers were coming together, we still had a massive challenge hiding underneath our data. Let me show you the data management gap we had to choose. We had to close. As I explained that we were using the Excel files and the other things. Okay, for years the data lived in Excel files scattered everywhere. Plus, we were using the SQL Server, which is hosted on the AWS for our legacy system. More than 20 years of rich data exists there. We needed a kind of a one single stuff, which where we can turn in everything from this old system to the AWS or to the Microsoft Fabric. Fabric gave us the ability to implement the proper Medallion architecture, where we have bronze, silver, and gold layers, turning the legacy data into clean, governed, reusable assets. With a gap of clearly understood, let me show you that how we implemented it. So this is the basic Fabric setup we have. Okay, we have the different workspaces for the which we use for the isolation, governance, and deployment. So we have a dev and test workspace and production migration. So whatever is first developed in the dev and test, then migrate to the production. We are also using the HubSpot. So from production, we are migrating the data to the HubSpot. So we provision a new capacity in Australia East because our everything is in the Australia East for the Skynet project. We created separated workspace for staging production with strict promotion control through the Fabric deployment pipelines and design approvers. Security was non-negotiable. Sensitivity levels at workspace and item levels were introduced. Row-level security for and data masking and we use the managed identities everywhere. For connectivity, we use the on-premise data gateway for the AWS SQL and the managed private endpoint for the SQL PostgreSQL, keeping everything secure and private. With the foundation ready, now let me show you that how we implemented it. So this is the actual stuff which we need to have it. So our data is in the legacy system. From there, we need to ingest into the Fabric. We need to have the transformation of that data and then push it into the our new system, the Skynet, which is the PostgreSQL database. And then from there, we need we when the database enriched with the new system, we need to push that data back to the Fabric, transform it, and push it into the HubSpot. So we have implemented the different levels. Okay, we broke the work into uh, these few levels. So there is a level 1 and 2 where we ingest the data into the bronze layer. We started by ingesting the data from the old system using the data factory pipelines, and then it becomes from. So I was implemented this data factory pipeline, I haven't started everything from like complex one. I started with a one simple copy activity, tested it thoroughly, and once it is scaled, then we use the loop lookup filter and for each loops to make it a proper pipeline. Then for level 3 and level 4, we did the transformation and silver layer. This was where a heavy lifting happened because the data should be transformed in a digestible level for the new system. So we use the PySpark notebook, which where it includes more than 66 tasks. Okay, and it's a kind of combined of the 2000 lines. Okay, the most important lessons I learned here was a strict separation that every task, once it is complete, it should do only one activity, and then we go to the next one. We never mix any kind of the layers. We always ingested raw data into the bronze first, did all the cleansing and schema transformation, and then we push the clean data into the lake house. So we have a different lake house for bronze, we have a different lake house for silver layer. Every transformation block was properly documented so that if anybody else in the team want to change it, they can maintain it later on. Then in the last one, in level 5, we did the consumption and pushed the to back to the Fabric. So finally, we push the transform data into the Postgres database, which becomes our new source of truth. We also handle the new transactions coming back from Skynet into the Fabric, send the updates to downstream to the HubSpot through the API calls. This journey actually taught me that good architecture is not just about the technology. It's about the discipline in layers, simplicity first, and planning for operational reality. Let me show you demo. Okay, give me a second. Okay, so now this is the kind of the real juicy stuff for the presentation. We have multiple workspaces as I mentioned before. Okay, I'm showing you the actual one, the staging one which we implemented. So we can use the different naming convention. Here we use the convention for the workspace with the company name, then the uh, staging, and then the workspace. Okay, and then the sensitivity level, and then so this is where we are showing the task flows. So these are not the pipelines, these are the task flows which like we can show to the management like how we are implementing the our work. So every task has some other items in it. So if the let me show you first. If you see there is a list of the all the tasks. Give me a second. So if I yes, so you can see the all the list of the tasks which are there. But if I select only one task, it is going to show you the only the items which are associated with it. So we have a first, which is the get data, getting data from the old system. Then we are storing it into the lakehouse, and then from storing, we are preparing using the notebooks to transform it. After transforming, we are storing it into the silver layer. Okay, and then we distribute to the our last destination of the Skynet Postgres. But as I mentioned earlier, that in the requirement was to first have a old data, transform it, push it into the new system, and after sometimes when it is being utilized and enriched, we need to get it back to the uh, fabric. And once we get it back to the fabric, okay, we need to store and push it to the new system of the HubSpot. So this first row of the task, which have the items, are only for the first system. Then we have the reverse ingest, as I mentioned here, from the Skynet to the Fabric back, and then storing it here. And the last, I have made a master pipeline, which actually contains a single pipeline, which is calling multiple pipelines. So let me show you. So actually there is a one master pipeline which is doing the multiple steps. So this is calling first the first part of the pipeline, which is which is getting the data from the old system to the fabric transformation and pushing it to the Skynet Postgres. Okay, let me show you here. Okay, so this is the first pipeline, which not the first one. Uh, from here also we can reach to the same destination. If I go here, okay, and I if I click on this one, so it is going to edit the first pipeline. So as I explained earlier, okay, I started with a very simple one. For that one, I will show you the simple one first, which is the last one. So this is the pipeline where we distribute from Silver to Postgres. And if you see that I simply created a single task first, because these are the tables. So we have to copy the table from the Lakehouse to the Postgres. So I created a simple copy task and then give the source, what is the information from where it is coming, okay, the Lakehouse, and then the where it is going, and then the destination, okay, the doing the mapping. And so once it is up and running, okay, then I actually come to this kind of point. This is the first pipeline where I already implemented the for each loop. But let me show you what it has done it, okay. That here I am getting the list of the tables from the old system. So if you see this one here, so we have a connection to the old system SQL, and I'm selecting only the tables which are required for my current implementation. Once it is I got the all the list, I'm filtering that tables with the proper naming, and then I'm passing that one for this for each loop. And this for each loop actually is going to run the number of the tables time here. So in my other example, in this pipeline we have around 6 or 7 tables, 1, 2, 3, 4, 5, 6. Okay, so instead of having this copy task 6 times, we can have a for each loop once, which is actually going to have the same copy task, and it is going to run the number of the tables time it, it got in this filtered one. So let me run this one. This is a bit big pipeline. It is going to take much time, but I will show you the first few steps just to give you the understanding that how this goes. Okay. So if I run it up, okay. So it is going to execute the first this get the metadata from existing SQL server. So if you see this one, it runs that one. So if I see the input for this, so the input is the whole number of the tables for this, and then the output is only the number of the tables with the information which I require, the table schema, group name, and the full table name, the number of the tables which I required only. Okay. So in so that's done, completed once. Then we filter the table names, because here we are getting the table schema, table name, and full table name. Here I'm minimizing that information also from this big information to the small only the tables name. So if you see here, okay, now we are getting the only 11 rows. That's once it is done, okay, then it is being used for the copy task. As I said that it is going to take a bit more time. Let me explain. Let me show you the which one is the easiest. Okay, so this is a bit quick. So if I uh, run this pipeline, so what the pipeline is going to do in the copy task, let me show you that the source is the lake house. So it is getting the data from the lake house, and then it is putting into the Postgres database, and it is showing going to show you how it is running for the first time for the first table, which is the organization table. And if you see this one, so it is successful. So it means the data is moved from the lake house to the, so this was the data from the lake house. This is going showing the information more about that task. But let me show you here. Okay. Okay, details. I'm not sure why it's not going back, but it is executing from one task to the second one to the third and all. When it is done for that one, okay, we will come back to on this one. So here I explained to you the master pipeline. The master pipeline is the first pipeline which is getting from the everything from the old server. Now I want to show you the actual transformation, how we did it into the notebook. So Microsoft Fabric as a one-stop shop, it gives provide us everything. So I not only ingest the data, I can also do the transformation of the full data, and then I can move it to the destination also. So this is the notebook which I wrote for our transformation. Before showing you the about the notebook itself, we need to connect before uh, run this notebook, okay. And there are multiple type of the sessions available. We can have a standard one and a high concurrency. In the high concurrency, multiple tasks can be run at the same time, okay. And we need to add the lakes also. So let's say in the notebook I want to do the transformation on some of the data lake tables, okay. Then I need to add that one as a data items, okay. So I added for the bronze and the silver also. Why? Because bronze has a raw data which I transform and push into the silver one. So let me start with the notebook. Okay. As I mentioned earlier, the key in the to save the time is to go with the step-by-step implementation. I haven't skipped any kind of the things. I started with adding the documentation so that any team member can use that one for the understanding. So here we have mentioned about this one that okay, this is the bronze create migration table. Okay, then we did the first the insert path one, but this is the first transformation. Some text form doesn't exist the individual account, so we need to have that one. Then we for the part two, that single text form organizations, we need to get that one, and how the tables are going to looks like after that. So this is the only the documentation we have added it. After that one, actually, I this is the first PySpark Python code which are doing the setup and configuration. Okay, once the setup and configuration is done, if you see, this is the output which is showing that okay, what's the previous task done. So I clearly printing it up here. The configuration is complete. Then how much time is taking it up. Okay, this time I have added later on, because when we were running this notebook many times, I usually mix it up that is this task is uh, that has been run for this execution or not. So I have added that time later on. This is one of the lesson learned. Then this is the second transformation. So we have done this one, the mapping the account type. Okay, if you see this one, this is the example in the text, and then I did the same implementation in the PySpark. Once it is done, and because it is executed, then it shows the okay, what has it done. So it completes the information. Then we did the task 3, where we are doing the mapping. Every time when the task is being run, it is showing the output with the actual information, so that we can know okay that every step is correct. Although it takes a time when you build it up, but actually it saves a lot of time later on. Once, because we can easily audit what is the requirement and is it filled it up or not. Okay, and secondly, if we miss anything, so like here also it is showing that what's the information done. So I have implemented around 66 tasks, and if you count it up, there are around 2000 number of lines of code. But these are kind of the manual steps which were we were doing before, or with the SQL uh, scripts. Here it's once done, okay, then we can execute it accordingly. So then we have a part two implementation. If I scroll it down with taking the time in consideration, okay. So we have all these steps done. So when it is done at the end, okay, what we are doing is we are showing, okay, that how how these tables are being created, how many number of rows are being generated with that one. So there is a client table which is being ingested with 150,000 records. Then we have this the team table with 4,400 records. Then we have like the user and client information, which is 175,000, and then the 130,000 rows for. So this is the actual implementation which we have done, where the three forms has been done, getting the data from the uh, SQL Server to the Fabric in the bronze one, then doing this transformation using the notebook, and then pushing it to the Postgres. So once the Postgres is update and running it up, then we re-get that data back to the Fabric, did some more transformation and push it into the HubSpot. So this actually gives you the information, and plus uh, all this implementation is been done because the it includes the data for the HR eyes only. So that because we implemented the that masking, even myself, okay, if I'm not in the group, I cannot see that one. So we have
Uh,
implemented the whole all the security stuff.
Hey, Gab, yeah, you just have like a couple more minutes, but yeah, that seems like a really interesting implementation. And I got like some questions on
Yes.
that, right? From the Python notebooks, like that you have in there, like I think they're pretty good, and you put like all the tasks in place, and you can visualize like what's happening, right? My question is not only related to the Python notebooks, but it's more related to the any sort of bottlenecks or limitations with Fabric when you're implementing like these pipelines. Like, what was your experience with that?
So one of the thing which I mentioned, that you need to have a capacity. So if you have a less capacity, then it takes a more time for a notebook to run. As our notebook, it's a quite big, 66 tasks, and it takes many times of the transformation. So we have to have a bigger capacity, which is expensive. So that's the one of the bottleneck. So when the people are implementing for their personal projects, they have to be considerate about that one, that how much data they are trying to transform. And that's the one thing which you need to consider. That's why I mentioned that when you are running the notebook, you need to start a session. And I would recommend that once the notebook is you already run, stop the session, because it is costing per second. So it's a VM which is running behind. Okay, so the cost, it depends on the company size. As we are a financial company, okay, we need a more kind of the, it's like uh, auditing and more kind of the accurate information. So that's why we have went into the more depth as compared to the individual or the small companies. Sometimes that level of the information is not required. So, and the second thing is this, as I mentioned, that we did one transformation where from old system, after transforming, we push into these Postgres. But after the that, we are re-ingesting into the Fabric. That was the crucial task of discussion, because whenever you ingest the data into the Fabric, it is costing you.
Yeah.
So cost is one of the matter when people who are using the Fabric need to understand. Okay. But Microsoft have many plans. I think if you coordinate with the companies, they can give you this some kind of the real tips which can save you a lot of uh, you know the a lot of time and money both.
Well, yeah. Well, thanks for the explanation. We're here like on time. Like, how can people reach out to you?
Yes, sorry. This is the last slide that I miss. Just one second. Yeah. Okay. Yes. So I'm available on the LinkedIn. Okay. And the GitHub both. You can see
Yep.
my screen.
Yeah,
Yeah.
I'm seeing. Yeah.
Yeah, yeah. I'm available on the LinkedIn app, GitHub, and plus I think we have a repo also where I will share my presentation. So you can go through about this one. Okay, we can have a chat about the fabric related or the Azure DevOps kind of stuff anytime.
Well, thanks so much, Cab, like for the time and sharing with us. Yeah, and you have a great afternoon, and see you next time.
Thank you for giving me the opportunity. Have a good time. Bye.
Cheers.